For mathematical modeling, as we said, we're going to be dealing with problems, real phenomena problems, whereby there might be for financial, there can be any mathematical problem that we can be able to generate the formula. So in this maths, we have two types of the problems. So some other problems, there will be changing. There will be a change. There will be a change. Maybe a change can happen in months. Sometimes it can happen in a year, a change. So when we have a change which can happen in a month, in a year, or after 10 months, or after 2 years. So this a problem, we describe them as a discrete problem. So a discrete problem is whereby something it can be happening in a monthly. And when we call it discrete, so it defined as we call it a differential equation. The formula that we're going to be able to, the formula that we're going to create, we'll call it a difference equation. Difference equation. I'll just say EQ. So we can just say DF sometimes, different equation. So now, we might be, for example, I will give an example based on let's say maybe what is it? A financial mathematics problem. You might go to a bank, maybe you have a saving account. Saving account. So in this saving account, you deposited 1,000 rand. You deposited 1,000 rand initially. Then the bank decided that they will give you 10%. 10% interest. 10% interest. So this 10% interest, it can be happening, unless it's gonna be a 10% interest, which is going to be gained monthly. Monthly. So now, as a mathematicians, we're gonna be needed to write to get a formula, whereby this formula is going to calculate how much we can use the formula to calculate any time. Maybe you want to find how much do you have in 12 months or how much do you have in 15 months. So we have to create our formula. So in order for us to create a formula, the first thing that we must know here in this mathematics is going to be in the form of a sequence. It's going to be in the form of a sequence. So the sequence, it will have an initial amount. Let's say, for example, our initial amount, we can call it A1, A0. So when we call it A0, our initial amount here in this formula, in this equation, we were told that the initial amount, we're told that we would a person deposited 1,000, or you deposited 1,000 rand. So when we're told that we deposited 1,000 rand, then in the sequence, there will be another, it can be, because it's a penny in a month, so we're gonna have A1. So A1, it can be 10,000, whereby we multiply by 10%. So if we use our calculator and we say 10,000, 1,000 multiplied by 10%, then we're going to get is 100. So which means the change now is going to be 100. It's going to be 1,100. Then when we go to term 2, which is A2, then after that, we're going to multiply this amount again by what? By 10%. So when we multiply it by 10%, then we're going to get, let's say, is 1,100. We multiply it by 10%, 0,1. Then we're going to get the interest that is going to be gained is 110. When we add it up, it's going to be 1,210. So after that, this sequence is gonna go until A4, then, but it will be going until AN, the last term. So now in this equation, if you check here, if we take the first element, these two elements, if we say A1 minus A2, we are going to get 100. Né? Every time when you take the A2 minus A1, you're going to get 100. And then even if you take not really 100, you're going to get the difference. You're going to get the difference. So the difference, then this take us to where when you're in grade 12, you used to do about the arithmetic sequencing. Arithmetic sequencing, whereby in arithmetic sequence, you find the common difference. So now we're going to get the difference, but this difference, if you may check, sometimes may not be the same. Because if from here to here, you will find that the difference is going to be 110. So, and so on and so on. So now when we get this different, in maths, we have something called a delta. A delta, it's a Greek word. It's a Greek symbol. So this Greek symbol, it means change. It means change. It means change. So change is represented by a triangle like this way. It means change. So which means the change between this sequence here from A1 to A0, the change between from A1 to A0, we can say the change between A0 is going to be A1 minus A0. And the change between A1 is going to be equals to A2 minus A1. And the change again between A2 is going to be equals to A3 minus A2. So if you check here, if we go until, you will find that in these changes here, the change within AN is going to be equals to, if you check, if it's A0, it starts with A1 minus A0, is the term after itself, and then again we subtract by itself. So in this one, if we want to check the change of this one, the change of AN is going to be a term after AN, which means the term after AN is going to be AN plus 1. Then when we say AN plus 1, which means the delta of AN is going to be AN plus 1 minus AN. So now this is we just got the formula. This is, we can call it maybe a general formula for the change, for the change. So now when we have this formula, we're gonna come back to it. We haven't answered, bear in mind that we haven't answered this question. I'm just still giving you an idea on how to calculate it. We're gonna come back to this one. So in mathematical modeling, what is happening? Hello?
The standard formula, this whole thing. I don't know the equation. Is this the initial standard formula I want?
No, hey, the formula yotoba for regarding the standard formula, ne? Ngori hey formula ndiyo ne ine musiba nayo idokono ubapa mini. Ikono ubapa every, no matter which question it is, as long as it's this kind of questions, idokono ubapa general formula bako shumisa hey. Ine bachi calculator but on one the values on the 1000, 1100 and 1200. Yes. So now Kai formula, the other thing that you must remember is that in this mathematics, mathematical modeling, what is happening, we want to know about the future. What will happen in the changes. So when we have a future, in this future, we also have a present. Ne? We can say a present. A present is the initial amount that we have here in this equation. Our present is 1000. And in this 1000 here, there is also a change. Ne? We can say a future is going to be equals to a present plus a change. So this change that we're talking about, it can be a change in this equation is 10%. It's changing. So every time the change, which is 10%, which is changing by 10%. This is just a rate at which a change is happening. So this change is here. It gets represented by a delta. So which means a delta is going to be a change plus a present value. Present value plus a change is going to give us a future. So our present value was 1,000 plus change. Then when we put it in terms of not only this question, we can say our future value is going to be in an initial amount. In terms of mathematics, in financial maths, it's going to be an initial amount. Initial plus what? Plus change. So a present future value is going to be, if we check in this graph here, the one, this graph that I write, linear line equation. So you will see that here in this an plus 1, if we are given an, this is a what? This is a future value, this is a future. And in this future, we don't know, we want to know what is happening. So after that part, we have a present. So this one is going to take as an initial. But if we can start here, this is our initial, and an is going to be a future value that we willing to know, to get. So now we can play around with this formula. So if I take this an to an, this an will change the sign, then an plus change in delta, which is also for an. So now this is a general formula that you can use when you are dealing with this kind of equations. So if we plug now, if we solve it, this equation, when we have an, let's say, for example, if we plug this equation, general, like, okay, this equation is missing. When I say it's missing with the, it is missing with initial. So when we write it, we must also have an A0. A0, it must also be given. So when you have A0 and this formula, then you can be able to calculate anything based on the question, any question of this kind. So now in this question that I'm doing, my A0 was equals to 1,000. And then when my A0 equals to 1,000, then my general equation, now I have to find a general equation. My general equation, the formula is an plus 1, which is equals to an plus. So now we need to find a formula, a way to know what is the changes there. So the changes, if you check something, the changes, what happen is that we take 10%, and we multiply it with the initial amount, which is what it can be an or a1. If we is a0, we're going to say a0 multiply by what? 0.1. Then when we say a0 multiply by 0.1, this is going to give us 0.1 a1, which is going to be equals to, when we add it, which is going to be, if when we check about the delta, which is going to be in the changes here, which is going to be equals to the delta, which is going to be a0, a1 minus a0. Then when we plug here, when we make this change, if we use the delta, when we say a1 and minus a0, we're going to get what? The difference that we multiply with, which is 0.1. So this changes here for 0.1, it keeps changing on what? At 10%. So when it changes to 10%, our equation, it will end up saying it's going to be equals to, for delta, is going to be equals to 0.1. And then when we say 0.1, what is it that is changing is an, because we don't know what will happen. So if I have this, I can simplify it. I say, okay, this, it can be equals to, this side there is also 1. So it's going to be 1 plus 0.1, which is going to give me 1.1 an. So which means my an plus 1 is going to be equals to this. So now I have just wrote a formula for a general equation for this equation that we are doing. So if I use this general equation, I plug, let's say for example, I need A1. I know my A1 is going to be equals to 0 plus 1. According to the equation, it's going to be 0 plus 1, or 1, A and 1, let me say 1 plus 0, according to the equation, then which is equals to 1, comma 1, A what? 0. Because I will put 0 here first, then I'm gonna get A0. So now when I say 1, comma 1, A0 is 1000. Then if we use our calculator, we will find that our A0 is 1, comma 1 multiplied by 1000, which is equals to 1100. So it's 1100. So if we check here, you will see that in our equation, the second term, which is A1, is 1100. So if you can do, we can also do maybe A2 using the same formula. We're gonna have A1 plus 1, which is equals to 1, comma 1, A1. So now we already know our present value. So A2, 1 plus 1 is A2, is going to be 1, comma 1 in brackets 1100. So if we use our calculator again, you will see that a 1, comma 1 multiplied by 1100 equals to 1210. 1210. So this one here, it just validates that everything that we are doing here, we are doing based on this equation. Everything that we are doing based on this equation, our formula, general formula, is fine. So this is the way of calculating, finding a general formula of any differential equation, difference equation. Do you have any question?
Okay, hapa lani ba na yoni kuri 1,1 iti.
Apa ke ya yante
Ntanya po ya.
Di abari ndi
Ne yeba wana one 1,1 iti. Ndio nenda kanda.
bakwamba ida wana 1,1 ne apa.
Ndio nenda kira one.
Oh, okay. Zwino chine chaite ati ti apa bana 1100 ndi initial amount. Zwino izi initial amount we hey into iko calculate wa mini difference yaone iko wana rate ko multiply nga 10%. 10% ri chi converter iri pa 0,1. Zwino i 0,1 ri multiply na mini na present amount. Present amount musi rika timeline yasho kana rika number line. Present amount ukhere na 1000 ndikangwana the second term ndi GA amount we nda I multiply nga 10% nga 0,01 idompa 100. Zwino ziyo no 100 ila 100 nda add na mini na way 1000 nda kono wana term number 2 yene ndaba ndisayidivi. Zwino zwamba zori mini khere ba cheka ndiri 0,1 multiply by what nda I multiply nga A0 ne. Zwino A0 is just the matter of is the first term. Zwino ngori comes icho chunga bakadiba bakonya go fimini ba calculate A mini A10 wakwebona kaso rapa ndi A10 ngamba zoti nne ndikango diva kuti A10 ndi bugai ndiko do jia 0,01 ndai multiply na mini na A9 ne ndido kono wana difference mini ndido kona rate ndai add na mini na A izindo no wana 0,01 ndido add na bugai ndido add na plus mini na A9 ne ndakona wana A10. Zwino hezwi ndi tshikoita ngorari he formula impo diri sumbe soroke zwamba zori mini uri hey zwithu zwoṱhe hezwi ri zwi wane ri nga ita uri an ra I multiply nga mini nga 0,1 zwamba zori if nṋe nda paya 1 hafha nda ri A1 zwamba zori nṋe ndi vha ndi khou press A1 hafha I multiply by 0,1 ndi vha ndi khou amba uri hey value ya A1 ndi khou I ḓivha carry A0 multiply by 0,1 ndi vha ndi khou amba uri A0 ndi khou I ḓivha ndi 1000 hama ndi khou I multiply nga mini nga 0,01. Zwino hezwi ndi tshi multiply nga 0,01 ndi kono wana the next term. Zwino kha general formula yashu hey 0,01 iba equals to mini delta ndiyone ya change delta A. Zwino I change okay
Richitsala hapa pasi vako vana una on your right onepa zwino afu uri nawe vaita bloko tharu dzo ndonga tharu anepo
apa
ya nepa there's a part here, Richibapa, on your there 1,1. I want to know or why percentage you know move from 10% to from 0,1 to 1,1. You move to that because the other part.
Oh, 1, okay. Ndi wazino ndikoba pfesesa question. Zwino key zwino kha ila formula bane ba khou i vhona yori mini AN plus 1 equals to AN plus mini change in AN, ne? Ba khou kona u pfesesa formula.
Ndikho ibona.
Zwino hezwi i formula ino vha ngo rali. Ri nga ṅwala AN plus mini change in AN ro wana uri ndi 0,1 AN. Vha khou zwi pfesesa zwino. Zwino musi ro no wana uri ndi 0,1 AN rina dzithu rina zwithu zwo no pfi dzi like terms and unlike terms. Zwino AN na AN is the like terms. So if rina dzi like terms, which means we do add mini when we have a like terms we add them. So hafha zwi ḓifana musi tshingwa una 1. Zwino zwi ḓifana musi ri khou ri 1 plus mini 0,1 ne ine ya ḓo ri fha mini 1,1 AN. Khere nda nga bvisa if ndi kho to vha sumbedza zwavhuḓi kha equation nda nga bvisa nda nga factorizer nda bvisa AN ndi kho ḓo sala nga 1 plus 0,1 in brackets AN. Vha khou vhona? Then 1 plus 0 zwino ḓo sala khori 1,1 AN. Ndio ya nda wanisa hone AN.
Oh, okay. Azwino ndikho zwi vhona nda khou balelwa u pfesesa ne part mara zwino
ndone ndo to zwavhuḓi ndo ḓi to simplify na musi khere vha soko iditsha yo to rali musi vha tshi shumisa i ṱoḓi vha fha the same answer but is better khere vho to i ṅwala nga heyi nḓila ivha i simpler, more simpler uri mini na musi vha khou shumisa na calculator vha zwi vhona uri ivha i simple nga maanḓa. Zwino vha khou kona u zwi pfesesa ne zwino khere vha khou kona u zwi pfesesa hey ndi one this is the only way of writing what if vana this kind of problem uri vha ri kone u ṅwala. Zwino ḽi a ḓuvha ra ro ḓi vula na iṅwe assignment randomly hu to vhori a thi ḓivhi zori iḽa assignment i gai ndi khou amba uri a thi ḓivhi zori like heiḽa question a thi tsha humbula zwo ra ro vula assignment ifhio khere vha kha ḓi humbula na iṅwe question ya vha i khou fana similar na hezwi zwine ra khou ita zwino. Mara ri ḓo ḓisa ndi ḓo i shumisa ndi ḓo shuma nga assignment ya present kha musi assignment 1 for now right one example ngo to ralo.
Okay.
So abare ndi delete. All right. So now zwino musi rina heyi nthui ro amba nga discrete tshine tshavha zwi discrete zwi amba zwori mini ndo vha ṱalutshedza ndi musi equation ndi musi rina ri vha na difference equation ne and it thinks that it can happen a month and it's something that it can happen a year or maybe after every 10 years is happening. So we also have something called ngabana nthu yene ya ba continuous. Continuous. So continuous is something that it could happen. It's always happening. It's always happening. So something that is always happening, we don't use differential equation. We don't use difference equation. We say we use differential. It's when we are differentiation. Differential equation. Sorry. Okay, differential. I will just say differential equation. So differential equation, there is a rate at which something is happening and this thing is continuous. So that's when we're gonna go to a question whereby we're going to find dy over dx. Or sometimes wangaba find a dx, you can say dx over dt, as long as we are differentiating. So the difference between these two is just as the other one is continuous. If it's continuous, we find a differential equation. We use this form, dy over dx. So this one first, I'm gonna teach you how to differentiate. Then after knowing how to differentiate, then we're gonna, there will be, although in a matter, but in a problem. Now, routine we're back on of pheasesa, if you mean, the one general formula your own. You know, about and check maybe a question whereby we can use to see. Maybe question in there show me for now. And the other thing maybe before I proceed, in this equation now goes on zibona uri hezwi zwithu zwa ri khou zwi ita kha discrete zwinga ndi sequence ine iba ikho ḓi tou thoma inga ḓi thoma kha A1, it's a sequence ya ḓa kha A2 A0 A0 A1 khamusi ya ri A2, then hei sequence ya ṱuwa until ya swika kha AN, inga ḓivha na futhi ya vha na AN plus 1 ne, and sometimes it can proceed ya vha na AN plus 2. It is possible. So hey question musi vha tshi check up la ro wana uri our AN here plus 1 is can be equals to AN plus meaning delta of AN. Zwino hey form sometimes when you are working vha wana uri vha khou shuma nga formula yone AN equals to meaning ingaba fha AN something like this, the one that we just got now. And sometimes hey formula vha wana if vha khou shuma nga AN plus 1 ingaba fha f of AN, for example f of AN. Sometimes bangono AN bachi shuma ngayo bachi kwana general formula iri n dot AN, so like that way. So we have something called autonomous. An equation it can be an autonomous or it cannot be an autonomous. Autonomous can be an autonomous or not. So, and what is an autonomous equation? Autonomous equation, the equation ine iba isina isa ko multiply nga n, hey n iba isi ngomwalo nga equation yaso. So if ba wana equation iso, this is not autonomous, it's not autonomous. Mara if ba wana equation yoto ngwalo nga hey ndira iso, ne, kana ichitoba in this format, usa isa ko multiply nga n, iba I autonomous equation.
So it means that every time parallel equation each go multiply on n, it's non-autonomous.
Yeah, it's not autonomous, yes. And if equation is a multiply nga n kha side ya iba I autonomous. Sometimes banga wana uri bachi ṅwalelwa banga muthu aba lecture nga ba ṅwalela so ya AN plus 1 ne equals to AN. This equation is not autonomous because if ba divide nga n, ba to divide nga n, Richie simplifier iba equal is still the same as AN plus 1, which is equals to what? 1 over n, ne? AN. This is not an autonomous equation. It's not an autonomous equation. So question is what is tell us if this is an autonomous or not. Then bafanolo check and go to ba check the difference yenda babudza yone. So if we go to your assignment number 1, question number 1 here. Question number 1 in 10 marks. State at least 4 main steps one needs to follow when constructing a model. So the steps here, first lesson, and the 4 of them is just this one is just a theory in your own words. In 3 lines, explain what is meant by mathematical modeling. What is mathematical modeling? Mathematical modeling, I have already given you the formula. Formula equals to future value equals to present plus change. So which means we are dealing with what? In mathematical modeling, we are predicting the future based on the present and the changes. So but you define the formula that I just gave you. So define the first order autonomous differential equation. So the first order, I already defined what is the difference autonomous in the equation in is a multiple n, ne? And then first order the equation in iba ichitoba na an fetsi iba ichikoba bangawana ichiri an, so ichiri an plus 1 yeah equals to an maybe plus something, maybe plus 2. Like this. This is what? This is the first order. Mara ichibobana an bawana ichibob an plus 1 equals to an plus 2. Maybe abana squared sometimes. This is the second order. It's no longer the first order.
Okay.
Musichibo increase and the second order. So that's the meaning of that. So when we go to this one, it said for each of the following difference equation. Now, but you want a word, remember difference equation, DE. We already spoke about it. Now you can calculate them. You say, classify the equation as neither autonomous or not, and as first order or not. So in this equation here, this equation is not a first order. It's not a first order. And when it's not a first order, this equation aina n is not multiplied by n. But this equation is autonomous.
Because you multiply Pn because of the
because auna of n times Pn. So that's why it's autonomous. Aina something like a constant. Zino, iri what u mu n u plus 1 equals to this equation here equal inner 6. A6 is representing n, and it can be any number. So this equation is not autonomous. And then after that inner 6, n minus 6, ne? U n minus 6, u n minus 6, it can be u of n minus 6, it can be a term below this one. It's a term below n plus 6. So this equation is a first order, but it's not an autonomous. And then the second one, inner minus alpha. Alpha, it can be a number, ne? Any number. So alpha is the same as n. This equation already is not what? Is not autonomous. And then in this equation, it's have b, delta, delta, beta, and alpha and the beta. So, but the equation is a first order and it's not, it's a first order and it's not, what is it? It's not autonomous. So, but the fact you have defined on what is where alpha is greater than 0 and beta is greater than n are both positive constants. So constant, it can also the same as n, because n, it can be any number. So this n here is this equation is not autonomous. It's not autonomous. So if but here for the question number question 3. Question 3 say find the general solution to the difference and differential equations. So you are given the general solution. We are given what? We are given an equation. When we are given this equation here, we have to find the general solutions to the following difference and differential equation. So we are given an equation. So equation we have pi is, it can be 3/4, and we have mu of n plus 1 equals to mu n equals to pi. So Richie calculator, but you go back to the equation that we used to do. Our equation is like that if we have an plus 1 is the same as equals to an plus what? Plus change, which is an change in delta, change in an. Ne? So the change in an, so this implies that now our an plus 1 minus an is equals to change in delta. Ne? So after that, it should change in delta. So an plus 1 minus 1 equals to change in delta. So after that, when it should change in delta, then we can take it from, okay, u mu of an plus 1 equals to mu of n plus 1. So in this formula here, the only thing, this is a general formula already as it is. It's just in this general formula, we must find, if we say a0 plus 1 is equals to, a0 plus 1 is going to be equals to mu 0 plus pi, which mu 0 we don't really know. So in this the general formula here, if mu 0, which is equals to something, and by mu n plus 1 equals to mu n plus pi. So the only thing that we add the mu 0 there. Because it's already been different. It's a difference equation, but in this difference equation, there is nothing you can do, because the only thing that we need in this different equation is to know what the mu 0.
Okay.
So to find the mu 0, it can be easier. How can we find a mu 0? We can still use this equation here. So if I say mu 0, if I put 0 here, I'm going to have mu 0, mu 1 minus mu 0 equals to pi. Ne? So when I get mu 0, mu 1 minus mu 0 equals to pi, then my mu 0 minus mu 0 is going to be equals to pi minus a1. Ne? Then my mu 0 is going to be equals to pi equals to a1 minus pi. Ne? So which means the general equation for this now, when we write it, is going to be mu of 0 equals to mu 1 minus pi, whereby mu of n plus 1 equals to an, sorry, the confidence amanda mu of n plus pi. So this is the general equation for this form, that one, number 1. Bokono ifesesa. Or okay, abandiye khabodo ne ndiba talutshedze nga equation.
Yeah.
So kayila equation rina mu tiro kwa equation mu n plus 1, which is equals to mu n plus pi. Ne? We know that already when a general formula refano diba mu 0. Ne? So to diba mu 0 karine refano diba zor meni ka mu n plus 1, which is equals to mu n plus min ridibazol edwana change ne of mu n. Ne? So change of mu n is equals to mu n plus 1. Ndikoto change ayenda isanga nge idori minus mu n. Ne? So if ndikango diba change of our change there is what? Even the pi. So change in there abanayo hapa, change of mu n is pi. Pi, our pi equals to mu, what? Mu n plus 1, ne? Minus mu n. So now if I put 0 here, ndidobana pi, which is equals to mu 1, 0 plus 1 is going to be mu 1, minus mini mu 0. Ne? Then I check this one, the other side is going to be pi minus mu 1 equals to minus mu 0. Because of this negative, I will multiply both sides by negative. Ne? Then it's going to say, when I multiply both sides by negative, it's going to say negative in brackets pi minus mu 1 equals to what is going to give us mu 0. So if I take this times this, we're going to get mu 0 equals to negative times pi is going to give us negative pi plus mu 1. Ne? Then I can rewrite this as mu 1 minus pi is our what? Mu 0. So then now, because I have gotten the formula of getting mu 0, when I write my general solution for that equation, I only add mu 0 equals to what? Mu 1 minus pi. Then I have completed that equation to be what? The general formula for that equation. Because with a different equation, we must have mu 0 in order for us to know the second term. Yes, that's what is needed there.
Okay.
So this one here, Number 2, bachicheka ina mu n plus 1 equals to mu squared 4n minus 4, which is equals to mu 0 equals to 2. In this one, we are given mu 0.
Before chapanda akanoni zvamba zvori uva kutishimiswa any other alphabet ingadiva d ingadiva z ingadiva mini
Even L vangadhiwana cho chipinga ka example vangadhiwana pachipiwa L afi L of u1 plus 1a. So as long as vane vakonodhiva kuitele kwahone, the letter it does not matter.
Oh, okay.
I matter na roti.
Okay.
So now ka equation e bopiwa mini bopiwa mu 0 now, ne? Hezo bopiwa mu 0 vapiwa futhi na equation k. Hezo bona po equation chine ringa ita chine ba ita. The first thing that you can do, you can calculate the first 3 terms of this sequence. But you calculated the first 3 terms of this sequence. The first term, we know that is 2. Then the second term, to get mu1, we're going to substitute 1, 0 here is going to be mu1 equals to mu 0 to the power 2, 4, which means it's going to be 2 to the power 4. 2 to the power 4, guy, is 2 times 2 times 2 times 2 is 16, ne? The 16 minus 8. Zambo, second term is going to be 8, ne?
Okay.
Then, raya third term. Third term, I mean, 2 1 2, rikoshimisa 8 is in. Numbers of 1 third term, rikodori mu 2, upper is 0. Mu 2 is going to be equals to mu equals to 8 to the power 4 minus 8. So after that, vachishumisa calculator, equal remaining calculator yabo ngane. Okay.
Ikomba 4,000 something or nendikotorwa zvitu zvisizvona.
8 to the power 4.
Ikomba, what's this? 8 to the power 4 ikomba 4,800. 4,096.
4,096, okay. Aban lesakwa checka nani hapa ka phone.
Okay.
Hey, iko doba pa 4,000, iko 4,488, ne? Yone beba wa a. So zwino, hey sequence idoba na an mu n, khato mu n. And ya doba 40 yabana mu n plus mini plus 1. So now rina hey formula. We know that in this question, for us to get mu n plus 1 is equals to mu n plus change in delta of mu n. Zwino, here's richi shumango rari. But the one or the difference between this formula, if we calculator, it have second different because after 8 rangari 4,088 minus 8, it got a difference in here, idoba equal manda, the difference. So hezwi ichi ri pa difference yana ya ḓo vha i khulwane. Then is gonna ndi hone hune ra khou fanela u shuma hone ri wane difference ine ri nga i vhea in this block here, then i kone u add yana heyi block. So the difference ine ra nga kona u i vhea kha iyi block, if ri khou checka zwavhuḓi, it can be
A8 rafha mafhedziselo i vha i si yone change yashu.
vha khou amba ifhio?
Verse 8 yena vha kha 3.2 afho 8 ine rafha ine ya khou ri -8 i vha i si yone change yashu.
I vha i sa tshavha change nga ndavha ya uri mini, hafha nṱha hu na 4.
Oh, because it's continuous.
Ina 4, hafha i vha i vho vha 4, so hii i vha i sa tshavha change. So the other method une vha nga u shumisa ne uri vha kone u i wana heyi, vha kone u wana heyi equation, ndi u i simplify, not i kha tou ri nga ita uri mini, ndi u i breaker into, khamusi vha nga i factorizer. U factorizer mara zwi ḓo dzhia, is gonna take much time. I ḓo dzhia tshifhinga tshilapfu. Divided by 8. Okay, so i ḓo dzhia tshifhinga tshilapfu uri ri bvise ri eliminate heyi 4. So which means in other ways what we can do, yeah, for hii zwi amba zwori a vha ndi ḓo tou thoma nda tou i shuma nṋe muṋe ne. Ngori ndi khou vhona ungari ndi khou ngo fanela u thoma ndi vhona uri how to eliminate heyi 4 hafha nṱha. Ngori ndi khou zama u checka uri if ndi vhona ungari i ḓo ri dzhiela tshifhinga, if nda nga i dzhia I can take mu n plus 1 nda ya ri plus 8, yene i ḓo ri equals to mu n to the power 4 ne. Then after that my mu n it can be equals to, nda i multiply nga 1 over 4 is gonna be mu n plus 1 plus 8 to the power 1 over 4 ne. Then mara no ndo no wana mu n i tshi ri mu n minus 8 here, mu n heyi minus 8 over 1 over 4 i ḓo fhedza i tshi vho ri fha kha formula ila ya uri delta equals to what, if answer i tshi bva ngafha tshi ya nga ngei, if ra movisa heyi i ri fha mini, change of the delta. So it's not gonna make sense, so I will have to work it out first properly. Ndi nga tou ṋamba nda vha ndi ḓo vha sumbedzisa ndo i shumisa hani. Ndi khou vhona ungari i nga ri dzhiela tshifhinga and i khou nyaga uri thome ndi tou i ṅwala fhasi zwavhuḓi ndi khou i analyze. All right, so we're gonna go to the next step. So now when we talk about dy over dx, so ri tshi amba nga dy over dx, ri vha ri khou amba nga u differentiate is the same as when we are finding f prime of x. And then f prime of x is the same when we are finding y prime. So between these two, they are the same thing. So if we are given an equation before in high school, you used to calculate, they will say find with a first principle, ne? Whereby our f prime of x equals to limit when h as approaches 0 of f of x plus h minus f of x over h. This was the first principle. So this principle, when we calculate, if you have y equals to, let's say 2x, it will give you the answer for differentiation. So now when we differentiate something like this, if I want to find my y prime, you just, because here there is a 1, also 1, you take this 1 down, it's going to say 2 times 1, x to the power 1 minus 1. So the answer will end up saying 2 to the power x to the power 0. Anything to the power 0 equals to 1, then the answer will come to be 2. So the general formula for y prime is the same as n x n minus 1. This is the general formula for the differential equation. So anything when we are differentiating, we can be given an equation, maybe y equals to x to the power 4 minus 8. So if I want to differentiate this, I want to get dy. When I say dy over dx, I'm changing. Okay, I want to find the change between when is y changing in x, this x here. That's why we say dy over dx. So dy over dx, it can be from x to the power 4. I'm going to take this 4 down. It's going to say 4 to the power x, 4 minus 1. And then when we differentiate the constant, a constant becomes 0. So it's going to be plus 0, which means the final answer is going to be 4 to the power x 3, 4 to the power 4 multiplied by x to the power 3. That's the differential equation. So in the differential equations, for this one, sometimes this one I'm doing it, I feel like they are more easier, because sometimes if you are getting something like y equals to x to the power 3 plus 2x plus 1, when we differentiate this, dy over dx is going to be equals to 3x squared. You take this 3 down, we subtract the 1 plus this one here is, there is 1 also here, is going to go down. It's going to be 2 times 1, then it's going to be 2. And this one, because it's just a number, is 0. We just leave it like that. So sometimes if you have y equals to, let's say 6x to the power 3 plus 2x, what happens when we find dy over dx? Our dy over dx equals to 2 times 3 is going to say 3 times 6. 6 times 3, x to the power 3 minus 1 is 2. Then here is 1 is going to say 2 times what? Plus 2 times 1 is 2. So 6 times 3 is 18, x to the power squared plus 2. So the differential equation, when we differentiate this equation, which one here? This equation, we get this. So this is how we work when we are working with differential equation. So we also have things like cos. We can use cos x, sin x, and tan x. So when we differentiate our dy over dx of cos of x is the same as equals to negative sin x, and our dy over dx of sin x is the same as equals to cos x. So cos x. So the only thing that you must take into account is that when you differentiate cos, it have negative. It changes to say negative, but when you differentiate sin, it does not have a negative. And our dy over dx of 10x equals to, what is it? I forgot. Okay, it's fine. We can work it out how to get it. So remember, when you don't understand how to do something, like now, let's say I forgot how to differentiate 10x. 10x, according to mathematics in grade 12, 10x equals to sin x over cos x. So when we differentiate, when we say dy over the x of cos x, we are differentiating sin of x over cos of x. Ne? So differentiating this, it goes to take me to some other rules, whereby I have to introduce you to rules called a product rule and a quotient rule and a chain rule. So when we go to a product rule a product rule. Actually, the answer I know that is going to be sec squared x, for this one, sec squared. But I just have to show you so that if you don't have a problem, if you have something very complicated, you must take all the rules. So a product rule is state that if I have a function, let's say my function is appendix
Yeah, I'll notice.
okay, so product function, product rule. If I have a function f of x, and I also have a function, let's say g of x, and I have this function h of x, but my function h of x, let's say h of x, function h of x equals to f of x multiplied by g of x. This is a formula. So when I want to find h prime x, remember, is the same as dy over dx. If I want to find h prime x of this formula here, of this equation, I will use a product rule. A product rule means that two functions, they are multiplying each other. Then, which means I will differentiate first f prime x. It's gonna be f prime of x multiplied by h of x, g of x. I will differentiate this function, then I multiply it with a g of x. After differentiating this function and multiply with g of x, I will add plus, then I will differentiate g of x, which is g prime of x. I multiply it with f of x. So this is a formula to calculate to differentiate two functions that they are multiplying each other. Okay, I'm gonna cancel here, delete here. So I want to give you a general, is very simple, meaning a countable example. Let's say I have my y equals to 2x square root of x. So now in this equation, I have a function called 2x. I also have a function again, which is square root of x. And before even I work with this question, when we say square root of something x here, do you know that we have two things in this equation, square root? We have a function called x, and we also have a square root of x in the same time. Is that this one, we call it is a composite function, composition, whereby when you say g of maybe f of x, it's a composition. If I let my f of x equals to x, and I let my g of x equals to square root of x, then if I say g composite f prime of x, it means that this x is going to be inside this one, it's going to be inside the square root, which means it's going to be x equals to square root of x. So there are two functions in the same time. So here now we're just going to assume that we have two functions, which is 2x and square root of x. So 2x is we're going to name it as f of x, and square root of x, we're going to name it as g of x. So now if I want to find my y prime, or dy over dx, let me just say dy also dx. This is the same as equals to, the first thing that I will differentiate 2x. If I differentiate 2x, now you know according to the rule that y prime equals to what? N y x, or n, okay, let me just say x to the power n minus 1 here. So this, if I differentiate 2x, is going to be 2. Then because it's anything to the power 0 is 1, we're just going to leave it like that. Then I will write square root of what? X, according to the formula of what? Product rule. I will add plus. Then now when I differentiate square root of x is the same as equals to x to the power 1 over 2. So when I differentiate square root of x, this 1 over 2 is going to come down. It's going to say 1 over 2 x to the power what? 1 over 2 minus 1. 1 over 2 minus 1 is going to give us negative 1 over 2, which we can say, simplify it as equals to 2 square root of x plus 1 over square root of x, 2 square root of x. Let me write this one properly. It's going to be 1 over 2. This is this 2 there, square root of what? Square root of x. So why did I write this? When you have 1, if you have something like 1 over -1, this is the same as 1 over x, ne? You write it like that. So if you have something like, let's say x to the power -2 is still the same as 1 over x squared. So if we have something like x to the power -1 over 2, this is still the same as 1 over x to the power 1 over 2. But we know that x to the power 1 over 2 is the same as a square root. That's why I wrote 1 over square root of x. Okay, so now using this, I have just found my dy over what? Dy over dx, ne? Equals to this. If it needs you to say to simplify it, you can also simplify it. When you simplify it, for example, simplifying it maybe is just a matter of maybe you can check, okay, the lowest common multiple, it can be square root of x. Then this one times this one, 1 over this one divided by 1 is going to give us the same thing, which means you're going to have 2 square root of x multiplied by 2 again square root of x, which we can just write. Let's say we can just write what? 4 square root of x times square root of x is going to give us x plus 1. Ne? This 1 divided by 2 square root of x divided by 2 square root of x is going to give us 1. 1 times this one on top here is going to be 1. So this is the same as you can write 4x minus or plus 1 over 2 square root of x. So we just found our dy. This one is just simplifying, or even if you end here, there is no problem. So the point of doing this is for you to understand how to find how to get a differential equation, how to differentiate using a product rule.
Yeah, ndikukona uyibona nyana ikubuya nyana ndikuti totiumela ndasedza matric nditowana the basic or ndikona utoiphi.
With
Yeah.
okay. Hey, Zvino, in this mathematics, you are going to work more with not only like from first up through maybe finally, you will be working more with the functions whereby those functions, they are ln x, can be ln x and ln e to the power x. So that between ln x and e to the power x, these two functions, they are inverse of each other. They are inverse of each other. When something is inverse of each other, if we plug someone in the inside of another one, it becomes 1. When I say the answer becomes 1, if we say ln, for example, if I say ln e to the power x, ne? Where there is x here, I put e to the power x. The answer here is going to be x. Ne? If I say e to the power ln x, like this way, where there is x on top, I put ln x, the answer is going to still be x. What is the meaning of that? It means that if I say e, ln of e, let's say here there is 1, ne? E to the power 1, the answer is going to be 1. And if here there is 1, if I say e to the power ln, if x was 1 there, the answer will be 1. So if you use your calculator now, you can try to use your calculator. There are these functions, ne? You will find that you get 1. Just try to put this one the way I've written there in your calculator. Then you will find that the answer is what? Is 1. So you can verify that. Then when you are done, you can let me know.
Sure. I think 1.
What was 1?
A.
Oh, okay.
Okay.
Okay. So now the formulas, normally what will happen is that you will be asked maybe, for example, you can get a equation y equals to x e to the power 2x. Ne? In this equation, we have two functions here. We have the function of x. We also have a function of 2x, ne? Which a function for x we can name it as f of x. And the function for 2e to the power 2x we can name as a g of x. Ne? So this function here we have y. So we can interpret it as like y is the same as f of x multiplied by g of x. Okay? So we can use a product rule. If we have to find the differentiation, we have to differentiate it. So when we use a product rule for our dy over dx, it's going to be equals to, we can first differentiate x. When we differentiate x, it's going to be 1 e to the power 2x, ne? Plus, when we differentiate e to the power 2x now, we're going to leave x. Remember, we leave x, then we differentiate e to the power 2x. When we differentiate dy over dx of e to the power 2x, e to the power x first, is the same as e to the power 2x, is the same as e to the power x. Ne? But if you have something here, let's say if we want to differentiate dy over dx of e to the power 2x, the first thing that we do, we write it as it is. It's going to be e to the power 2x. Then we differentiate what is on top there. When we differentiate what is on top, differentiation of 2x is the same as 2, then which means you're going to write 2. So when we write it properly, it's going to be 2 e to the power 2x. Ne? Then second thing, if we have, let's say we want to differentiate e to the power x squared, you see, there is x squared there. Our dy over dx of this is going to be e, we write it as it is going to be e to the power x squared. Then when we differentiate this one here on top, is going to be differentiation of 2x squared is the same as what? 2x. If you remember how we did it. If we say x squared, this 2 goes down, is going to be 2. Then x minus 1, there is going to be 2x. So it's 2, right? 2x. If we are writing it properly, this one, it can be 2x e to the power x squared. So I just want you to get familiarized with how you differentiate x, e to the power x. So now if we are differentiating this one is going to say 2 e to the power 2x. Then if we are rewriting it, is the same as e to the power 2x plus 2x e to the power x. And we have something in common there, which is what? Which is e to the power x. So you can take out e to the power 2x. Then we're going to be left with 1 plus 2x, close brackets, e to the power 2x.
Yeah, ndikokona uivona nyana.
Akone vana va ḓo to dovholosa futhi zwavhuḓi kha video mara khere vha vha na fhethu hune vha vha sa khou zwi pfhesesa vha mbo uri vha nga mbudza uri vha nga mbudzisa uri at least vha vhe clear. So now we have discussed about the product rule and we have discussed about the e to the power x. So we're going to go to what about if you are working with ln of x. So the differentiation of ln x, dy over dx of ln x is the same as equals to 1 over x. When we differentiate ln x, the answer becomes 1 over x. So if we have ln of x squared, the answer is 1 over x squared. Then we differentiate what is on inside here, the x squared. The x squared is going to give us 2 to the power x. And when we simplify this, this is the same as 2x over x squared. So you're going to cancel this and this one, there one. Then you're going to remain with 2 over x. So if we are differentiating, sometimes you can find that you are differentiating ln of, let's say, square root of x. So to differentiate ln dy over dx of this is going to be equal to 1 over square root of x. But when we differentiate square root of x, remember square root of x is the same as x to the power 1 over 2. So it's going to say, when we differentiate 1x to the power 1 over 2, it's going to say 1 over 2 in brackets x to the power negative 1 over 2, which is still the same as 1 in brackets 2 square root of x. This is, I'm using this x there. And then this one also is the same as square root of x, ne? Because when we take it down, it's going to be 1 over something also. Then the final answer will be 1 over 2 square root of x multiplied by square root of x. We know that the answer is going to be x, ne? Then the answer will be 1 over 2x. So this is how you differentiate square root of ln square root of x. So it's just the matter of practicing.
Yes.
So now you know how to differentiate ln x. Sometimes you might be given y equals to x squared ln x. So we have to use the product rule, differentiate it. So to use the product rule to differentiate it, y prime is going to be equals to, with start with x squared, is going to give us 2x ln x plus, then we differentiate ln x, we leave x squared as it is. We differentiate ln x is going to be 1 over x. So when we simplify it, it's going to be 2x ln x plus x, this x will cancel with that one, there is going to be plus x, and then the answer here, we can just take out common factor is 2 ln x plus 1 over x. So that's how you differentiate with a product rule. So we have talked about the product rule. I'm gonna go to the quotient. I'll go to the quotient rule. The quotient rule, a quotient rule is when you are dividing, if you have h of x, you will have f of x over, let's say, g of x. So the formula to differentiate h prime of x is the same as equals to, you make a g of x, you write it as it is, then we square it. Then after that, when we square g of x, we differentiate on top f prime of x first. Then we multiply it with g of x without differentiating it. Then minus, then we differentiate g of x. Then we multiply it with f prime of f of x. This is the formula for differentiating what? H of x. So now we have to differentiate the y over the x of sine of x over cos x. So when we want to differentiate this, which means using our formula that I just gave it to you now, we're going to square this one. It's going to be cos of x squared in brackets squared. Then we differentiate sine x. Sine x, we know that is going to be what? Cos x, ne? And then multiply by cos x, this cos x here. Then minus, we differentiate cos x. When we differentiate cos x, we know it's going to be minus sine x.
Minus sine
X, because cos x, I already showed that when you differentiate, it changes the sign. It becomes negative sine x. Then we multiply by sine x, which is this one on top there. Then cos x times cos x is the same as cos squared x, ne?
Yeah.
And then this negative is gonna be plus. Sine x times sine x is the same as sine squared x. Over this one cos squared to the power is still the same as cos squared x. We can just write it as like this. So according to the identities in grade 12, you know that cos squared x plus sine squared equals to 1. We have the formulas whereby I'll write them down here. If you have cos squared x plus sine squared x, this is equals to 1, né? And this cos squared x equals to 1 minus sine squared x, né? And sine squared x.
Is the trigonometric identities the denominator?
Yes, this on here. Sine squared x equals to 1 minus cos squared x. And then if you have cos, I'm just giving you so that I don't speak about them. If you have cos of A plus B, this is the same as equals to cos A dot sine dot cos B If it's plus here, it changes the sign to minus sine A dot sine B. Now, now sine for sine of A plus B. For sine of A plus B, when you use sine A dot cos okay, so about 2 minutes, eh?
Okay.
I see this transaction here. I want this subtracted in Facebook, what. All right, so yeah. Amara will investigate it later. I just stop my card there. Okay, so question in there, then which means here when we write it is going to be equals to cos squared x plus sine squared x is equals to 1 over cos squared x. So we know that the reciprocal of sine x, we have cos sec x is the same as 1 over sine x, and cos sec x is the same as equals to 1 over cos x. And then cot x is the same as equals to 1 over 10. 1 over 10x. So now, Rina, hey, this means the answer for this one is the same as what? 1 over cos squared x is the same as sec squared x. It's the same as 1 over sec squared x, sec squared x. So, which means dy, the reason part we have to do this is because of we have to find, I wanted to show you how to find dy over the x. So dy over the x of 10x is equals to sec squared x. So this is how we normally get it. If you have all this knowledge that I'm teaching you now, so which means based on the product rule and the quotient rule, you won't have any problem. So is there any questions?
No, so far ndikuti zvivananyana ndikuda kuti tovaro ndiumerevo kadzinotso dzanga dzamuraho ndivone these things and then nditova right. But ndina kuzvivona zvozvikaira guy.
Oh, okay. So, Zino, there is a part most in this cover by Makovana dy over a petty chamber tin and koshumanga dy over dp ne dx ne hapa zwino vha khou pfi dp over dt. Why I khou pfi dp is because of vha khou vha no hey question yo composed nga mini nga t na p and the question I khou shumisa na e. Zwino vha vho kona u ḓivha zwori vha tshi differentiate e vha I differentiate hani. Mara if ri khou shuma equation, if you want to find a general formula for this question, I'm gonna write it down in the board here. So hela question iri dp over dt equals to e to the power t over e to the power 2p. So now when we want to find a general formula for this equation, the first thing that we're gonna do, ba multiplier abandi ngwadelise zwavhuḓi ya ndi khou vhona ngathi ngo ṅwala sharp ni ngothi nda ndi khou dp over dt equals to de to the power t over e to the power 2p. Ba multiply first with dt, ne? The multiply both sides with dt. Multiply both sides with dt. This is the first step. When we want to get a general formula, this will cancel with this. Then you're gonna left with dp, which is equals to e to the power t over e to the power 2p dt. So now we're gonna have to eliminate this one this side so that it can come this side. We will multiply by e to the power 2p, ne? Right, multiply this side also by e to the power 2p. Then this will cancel with this. Then our equation will be e to the power 2p dp, which is equals to e to the power t dt. Ne? Then we're going to introduce an integral. When you introduce an integral, you put an integral, you put an integral. So when we put an integral, the integral of e to the power 2p or e to the power t is still the same as what? E to the power t. We can say e to the power t plus c. But the integral of e to the power 2p is going to be the same as we use a rule of substitution. So now, a rule of substitution, I'm still going to repeat this chapter. I'm just showing you how you work it out. So we let our we can let u equals to 2p. Then our du over dp is going to be equals to 2. Ne? Then when du over dp equals to 2, then we can multiply by our du is going to be equals to 2 dp, ne? dp, with multiply by dp. So now our du equals to 2 dp. If we put e to the power u, because u is 2p, u is going to be e to the power u is going to be equals to 2. Is going to be equals to 2 dp. So 2 dp, we only have dp here, which means we can divide by 2 both sides here. We're going to have 1 over 2 du is going to be, we're going to write 1 over 2 du. So now when we have written this is the same as 1 over 2 integral of e to the power u du. And e to the power u du is the same as 1 over 2 e to the power what? U only. So now I can substitute back to this equation. My u was what? My u was 2p. So which means if I substitute back, my answer for this one here is going to be e to the power what? 2p 1 over 2. Ne? Ndiko bakedza. Hello?
Sorry. That part you never could introduce a UT.
Hey.
You're the answer, Zanyana, because I thought we were differentiating in terms of T, DT, and DP.
Oh, yeah. So about the equation, ne? I will ndito thoma nda imanyana for here. Ngauri problem hapa ndiko fana bafunza nga zwithu zwa substitute like differentiation, nda bafunza nga u substitute. Nda bafunza nga u ndona zwithu zwinzhi zwine nda fana bafunza. Kha heyi hapa yo no differential equation ine yo no differentiate wawo and iko nyango to female riba ri shumisa integral. So integral is another chapter on its own.
Okay.
So that's why basingasi ngori ndichi shumisa rule of substitution. Baba sa professor why ndi zwino ndichi dzhenisa dzi u. So I will have to teach that. Ndi ḓo fanela vha funza heyo rule uri ri shumisa hani. So for today, for mathematical modeling, ndi vhona ungari at least vha vha kona u ḓivha uri if bana huna differential equation by one is hani, like these ones here, the ones we're doing in, and then how to construct if both were word problems, but the construct is hani. Ufara zwino I will say carbon ka exercise ndi ḓo vhafha ka assignment 1 question number 5 ina 10 marks. Consider the differential equation. What differential equation k? Then if u equals to 0, cover 1, find mu1 and mu2. Is very simple there. Determine all the equilibrium values of the differential equation. Determine the general solution of the by na yone bangaita ya. So about the answer 5.1, 5.2, 5.3. So ine comes bangaito is here kerba sakwe and the equilibrium values. You say equilibrium values. Ndio ine bangayisiya mara at least cover 5.1 just to uri bakone ukona uri ukhoita yamini. Then I'm gonna go to Octave now. When I go to Octave, I will open my app for Octave. So the first question that I did there, yeah, Octave.
Okay.
I think I made a mistake. Oh yeah. Octave. All right, yeah. So in that question that Mangayo, yeah, 1000, we can code it in the Octave. Ne? We code our Octave. Programmer. We already know how to get the differential equation. We already know how to get the differential equation. Ne? Yeah, equation here, question. One or differential equation here, an equals to what? An equals to an was equals to 1,1 an, ne? An plus 1. So now we can code it. When we code it, we can say, for example, we can write it with 1. For example, we can say 1 equals to, oh, why is not typing? We can say maybe even if we can use even, let's say 1, we can make our 1 equals to, we write a recurrency table. Let's say recurrency table, this is just the name, recurrency table. I'm gonna explain everything that I'm doing here. So when we say recurrency table, our formula, it was based on the A. Ne? So when it was based on the A, I will put the braces. When I put the braces, I'm gonna name it as an A. It's a name, it's an plus 1. Remember the formula was an. The formula was an, n plus what? Plus 1. Ne?
1A.
Then we're gonna make equal sign. Then we got that our formula, when we get it, it was 1, 1 multiply by an plus 1, ne? A of n. So we're gonna put a comma there. So our A of 0, was equals to what? Was equal to 1,000. The initial amount was equals to 1,000. I will put a brace. When I put a brace there, we're gonna put a comma, we put A and a comma again. We put a brace again. So when we make a brace, we're gonna have an N and then comma, we're gonna have a 0. A 0, it means a starting point. And we can tell it, okay, we want maybe to know the first 10, maybe 12 months. Let's make it for 12 months. Then when we make it for 12 months, I'll put a brace there. So when I put a brace here, this is just telling, it's just a recording of the formula. So this formula, I already written a formula that, okay, I need to write, I need it to generate what? I need it to generate something like this, but in terms of my, what is it? In terms of, I want it to start from 0 until 12. It's going to mark 0, it's going to mark 1,000, 1,100, 1,210. It's going to repeat the answer until number 12. So let me just check if I didn't make any mistake. Data mistake, just a small mistake. Don't worry, 4 a 4 instead of the A of 0, not 4. A of 0 is similar to 1,000, which is fine. Then udobana brace, comma, Z is fine, comma, then comma in brackets, okay, brace and N and 0 and 12, and then brace is fine. So you know, iba isharp way. You know, most right. Hey, formula yenda ita hapa, you know, ido ripa mini, ido ripa table all this amount. So ikombuta hey formula is wrong. I will try to check where the problem is.
Avadombuza zvino kono dzhena afho kha Octave avononga khamusi ndi ḓo to xela zwa serious zwino.
Oh, or ndi vhaitele khamusi vhathu vhe vha practice nyana ne.
Zwino zwi yono dzhena afho ti.
Eh.
Hai zwino confused uri afho zwino.
Oh, okay. Ya ava ndi vha fe break. Then vhathu vhe vha ite vha shome vha shumane na zwe ra vha ri khou zwi ita, then ri ḓo zwi ita nga zwavhuḓi step by step.
Because Octave thi to ivula ubva tshe nda installer ndi thi to ishumisa.
Oh, okay, and because we pfesesa. Then which means uri ḓo imanyana khamusi 1 hour. If ri khou ima 1 hour zwi amba uri i ḓo vha class i ḓo vhuyela nga tshifhinga ḓe. Ya I tshi khou ya kha vho
I khou ri 20 to 10. Zwino i khou ri 20 to 10.
Zwi amba zwori ri nga ima for i ḓo vha nga tshifhinga ḓe. A thi khou tou ava ndi check.
Okay.
Zwi amba zwori ndi ḓo checka tshifhinga, zwi amba uri ri ḓo amba uri ri ḓo zwi itisa